Hi, I am researcher Nai. It is believed that humans form societies by nature, and to thrive in today's highly complex and fast-changing social landscape, a massive amount of brain power is required to remember not only individuals but also the relationships between them. Here we will talk about two studies that try to see just how our brains respond to the world so that we can conduct our social life successfully. Researchers in the first study used functional magnetic resonance imaging, fMRI, to record the brain activity of 88 participants while they were playing a simple game. The study participants were divided into teams of two, and each participant was given a series of information about how oneself, S, his or her partner, P, and the opponents, O1 and O2, in the opponent team were performing in a game. The participants needed to keep track of such information in order to answer a question comparing performances of different players. The study tried to find out whether our brains would use an agent-centric frame of reference, where each player's performance would be tracked by specific parts of the brain, or a sequential frame of reference, where the information would be tracked in the order it was received. Researchers found that both approaches were used, and our brains were able to simplify such information into small chunks. In fact, researchers were able to identify specific patterns of activity in the brain that could be interpreted as some building blocks, each representing a pattern of interaction between the players. For example, one building block kept information about how well a participant and the partner were doing relative to the other team, S plus P versus O1 plus O2, without referencing exactly how each player was performing. A bigger difference in performance between the two teams corresponded to an increase in brain activity related to this building block. These specific patterns of activity were found in the prefrontal cortex, which is involved in decision-making and social behavior. As we conduct our social lives, our brains are getting familiar with specific interaction patterns that we come across again and again. So these patterns may become hardwired into the brains as building blocks that get assembled recurrently to construct our understanding of any social setting. In the second study, researchers conducted an experiment with 83 participants who played the prisoner's dilemma game, a scenario in which players interact with a partner and choose between cooperating for mutual benefit or acting selfishly. The participants won 30 points when both they and their partner chose to cooperate. The payoff was 60 points when the participants defected and the partner cooperated. On the other hand, when the participants cooperated and the partner defected, the participants lost 30 points. When both parties defected, the participants earned nothing. The points were accumulated across trials and the cumulative score was shown on the task screen. In each trial, participants played with a member in their groups, and the size of such groups ranged from 2 to 6 people. Participants were allowed to leave groups they found undesirable or remove uncooperative members. Throughout the game, participant brain activity was monitored using fMRI imaging. Results showed that overall people cooperated more frequently, with 57% of all decisions being cooperative. The tendency to cooperate increased as group size grew. Researchers noted that while group size itself did not directly promote cooperative behavior, it influenced how people managed memory and made decisions during social interactions. When participants struggled to recall past interactions clearly, they usually would follow their default inclinations to cooperate and adopt pro-social behavior. This suggested that when memory becomes unclear, in general people would rather cooperate than to do otherwise. Researchers learned more of such decision-making process through brain scans. Specific brain regions like the fusiform gyrus and precuneus handled memories of past interactions, and the nucleus accumbens processed feelings of reward related to these memories. Then, the prefrontal cortex would integrate all of these with personal tendencies, deciding whether one would cooperate with others who might have previous betraying behavior. The efficiency our brains provided to cope with fluid social settings, as we have seen above, is amazing. But is that enough for living a good social life? It is interesting that we are depending on forgetting and basic instinct rather than remembering and reasoning to cooperate with others, but what will happen if that pro-social inclination was weakened or even changed to an anti-social one, given the ridiculous events, the wrongdoings and sufferings the world has witnessed over these recent years? Will we face a total meltdown of our society? Then, even we can still form and maintain a team, if all we concern is the total work done by the whole team regardless of the contribution of each individual member, we may simply give up the whole team, or the team may discard us when the opponent team beats us. In the process, we may lose the talented guys in the original team, and join the next one that as a whole may perform better but can't shine for lacking members that are really excellent. Hopefully you will find this episode both interesting and thought-provoking. It is also appreciated that you will keep your curiosity towards trending topics in NeuroAI. Until we meet again.